So equations. So in this video, we're going to talk about how to solve equations. And so we're just going to go through the basics first. So what is an equation? Well, an equation is just a statement of equality. It could be as simple or as complicated as you like. So something like 5 equals 5. That's pretty simple, right? 5 is the same as 5. Or you could do something a little more complicated, like 2 times 3 is 6, right? So saying that 2 times 3 is the same thing as 6. You could make it a little more complicated, throwing a variable in there. So something like x plus 2 equals 5. So those are all examples of equations. So a solution to an equation is a number that makes an equation true when we have a variable. These guys don't have variables, so there aren't really any solutions, right? We already know everything there is about the statement. But this guy, x plus 2 equals 5, there's some missing information there. They don't tell us what x is. It just says a number plus 2 more should give us 5. Well, what is that number? What number plus 2 gives you 5? I bet you can guess. 3, right? So if we put 3 in, plus 2 is equal to 5. So we would say 3 is a solution to x plus 2 equals 5. Because when we put it in there, it makes a true statement. Well, we could figure out what the answer was here, but what if we had something more complicated? We need to use some properties of numbers to be able to help, or of equations, to be able to help us solve these. So, if we look at my first statement, 5 equals 5, well, that's definitely true. 5 is equal to 5. But what happens if I add a number to both sides? Is it still a true statement? Okay. Yes, it is still a true statement. We get 7 equals 7, which is definitely true. So what we did was we rewrote the equation above by adding the same thing to both sides. It still keeps the equation true. So could I have replaced this with 2 with any number and still get a true statement? You bet. So I could have used 243, I could have used 12, it doesn't matter. As long as we add the same number to both sides, we still have a true statement here. So how does that help us with these guys? Well, if I'm allowed to add whatever I want to both sides, if I can get this to look like, something equivalent to the one I have above, to look like x equals some number, okay, I know what the answer is to that. I know the solution and without having to guess, right? So what you do, if I want x to just be by itself, I would write what number, when I add it to 2, gives me 0, so that would just leave me with x by itself. Well, how about negative 2? But if I added it to the left side, I also have to do it to the right side. So over here, I get x plus 2 plus negative 2 gives me 0. 5 plus negative 2 gives me 3. But any number plus 0 is just itself. So I get x equals 3. Ta-da, there's my solution. So what we did, we took and we wrote statements that are equivalent or maintain their truth to the previous one until we get the simplest statement we can, x equals 3. Okay. So that is how we use this property of adding to both sides to be able to solve these equations. It actually works for multiplying on both sides as well. So instead of adding 2 to both sides, I could multiply by 2 on both sides. Do I still get a true statement. Well, yeah, because 2 times 5 is 10 and 2 times 5 is 10. So I can multiply on both sides by the same thing and still have a true statement. So that's not so useful in helping us solve equations like x plus 2 equals 5, but it is useful for something like 1/2 x equals 3. So if we wanted to solve something like 1/2 x equals 3, well, I've got this 1/2 over here, right? If I could just have it be 1x, right, I would have the answer. So what can I multiply 1/2 by to get me to 1? I'm thinking 2 is a good number to pick. So 2 times 1/2 gives me 2 over 2. And 3 times 2 gives me 6. But what 2 over 2 is 1. And 1x equals just x. So I get x equals 6. So that means the solution to my equation is just 6. And you can always check your solution by plugging that number in for x and seeing if it works. Sure enough, when I do 1/2 of 6, I in fact get 3. So that's how we use the multiplication property to solve equations.